Hello, calculus students and seekers of truth. Welcome to another example of integration by parts. This time x squared e to the kx, and I should make a note here, k is constant. That should have been given in the problem. I apologize for the omission. Alright, so we can assume that k is some constant. Okay. Alright, now, so we have to decide again what are we going to pick to be f and what's going to be g prime. And I'm going to choose x squared here to be f and e to the kx to be g prime. The reason being is that if I take the derivative of x squared, it's going to get simpler. And if I take the antiderivative of e to the kx, well, I know how to take it to begin with, and at least it won't get more complicated. Okay. So this is equal to, and I'll just write out the work here, f times g minus the antiderivative of f prime g dx. Okay. So just plugging in what we have here, f here is x squared, g is the antiderivative of e to the kx, so that would be e to the kx over k minus the antiderivative of f prime, which in this case is 2x, times g, which is e to the kx over k dx. Right? And you look at this and you go, oh, well, wait a minute. We used the integration by parts rule, and we got this integral, but this integral is actually not easy to calculate. We can't really do this by substitution. You can't really do it by any method you know, because of this x right here is a little bit problematic. Okay? So what we're going to do is we're going to clean this up, and then we're going to use integration by parts again. So this is equal to x squared e to the kx over k. I'm going to pull out the 2 and the k, just so that our integration, the next part of our integration, will be a little bit simpler. Okay, so now I'm going to integrate by parts again. Okay, this expression here, this integral right here, I'm going to integrate it by parts. And just as before, I'm going to choose the x variable to be my f, and the g prime to be e to the kx. So let's see. Let's make sure we get all this stuff in line. X squared e to the kx over k minus 2 over k. And now our integration by parts will happen inside of these square braces here. So this part here is g prime. Okay. So we're going to start with f times g. F is x times g. Since e to the kx is g prime, we have e to the kx over k minus the integral of f prime. Since f is x, f prime is 1. And you see how choosing x squared here to be f was very advantageous for us, because at each one of these steps the problem gets a little bit simpler. G, this is f prime times g, so we have to take the antiderivative of e to the kx. So e to the kx is e to the kx over k, again, dx. Okay. So now this antiderivative, maybe we can pull out 1 over k. Okay, so I'm just trying to make things simple. Oh, and all the other stuff in the front we still have. Okay, should be a minus sign here. So the antiderivative of e to the kx, well, is e to the kx over k. So this is 1 over k times e to the kx over k plus the constant. This whole thing, well, I won't add the constant in yet. this whole thing is supposed to get multiplied by 2 over k minus x squared e to the kx over k, and then we can add our constant here at the end. Okay, and this right here is the antiderivative of the original problem that we were asked to solve for. Okay? Now this is a correct answer. If you are taking an AP exam or if your teacher requests it of you, you will have to be able to simplify this in order to get the correct form. Okay, so oh, wait a minute. I think I made a little mistake here. I've made a mistake. I forgot to add this part here. So this term right here, I forgot to write in my final answer. Okay, here we go. So there's a minus sign there. Okay. All right. So to simplify, inside of these brackets we get xe to the kx over k minus e to the kx over k squared. And that whole thing gets multiplied by negative 2 over k, and you still have x squared e to the kx over k out here. Okay. And this in here, I'm going to multiply the top and the bottom by k, so I get negative 2 over k x k e to the kx over k squared minus e to the k, which is going to give me, when I multiply this out, it's going to give me negative 2xk e to the kx minus 2e to the k over k to the third. And don't forget this term up here that this term right here that we need to bring along to the very end, x squared e to the kx over k. Alright? And this is, I think, good enough for us right here. You could probably continue on and get it down simpler, but at least you get the idea that you're going to have to somehow merge these two things together. Actually, I'm just going to go one more step. X squared k squared minus 2xk e to the kx minus 2e to the k all over k cubed. Okay, so all I'm doing here is multiplying this term by k squared over k squared in order for me to get k to the third here on the bottom. So don't get too lost right now in the simplification. You will have to practice that as you do your homework and your assignments, but make sure you understand how to do integration by parts, and especially in the case where you have to repeat the process. Thank you for watching. Have a wonderful day.